In question 5 of this exercise, the problem statement says, in a triangle ABC, angle C is equal to 3 times angle B is equal to 2 times angle A plus angle B. Find the three angles. Now, this is a problem that does not really require us to set up a pair of linear equations in two variables. We can even solve it by setting up an equation in just one variable, and let me first show you that, and then we will see how we can do this by setting up a pair of linear equations. So I'm going to do this using two approaches. So let's call the first approach 1, and in this I'm going to use only a single variable. So I have angle C is equal to 3 times angle B, so I'm going to assume that angle B is equal to x degrees. This means that angle C is equal to 3 times angle B, or 3x degrees, and then from this pair of terms being equal, I have 3 times angle B is 2 times angle A plus angle B, or 2 times angle A plus 2 times angle B, and this gives me angle B is 2 times angle A, which means that angle A is half of angle B. So I can write this as angle A is equal to x by 2 degrees. So what I've done is I have written all the three angles of the triangle in terms of this variable x, and now I can use the fact that the sum of these three angles should be equal to 180 degrees, and this means that x plus 3x plus x by 2, the sum of the three angles, this should be equal to 180. And what do I get here? I get x plus 3x is 4x, and 4x plus x by 2 is 9x by 2. So 9x by 2 should be equal to 180, or x should be equal to 180 into 2 by 9, or 40. So x is 40, which means that angle B is equal to 40 degree, and angle C is thrice of angle B, so that this should be equal to 120 degree, and angle A is x by 2 degrees, so angle A should be equal to 20 degree. So that's the answer. Angle A, angle B, angle C are 20 degree, 40 degree and 120 degree respectively. So we did this without assuming two variables, but now let's do this same problem by assuming two variables. So let's say that angle A is x degrees and angle B is y degrees. So let's see what equations we can set up in x and y. So if I compare this equality, 3 angle B equal to 2 angle A plus angle B, I can write this as 3 angle B, or 3y is equal to 2 times A plus B, or 2 times x plus y. So if I expand this, I get 3y is equal to 2x plus 2y, and this I can write as 2x minus y is equal to 0. So this is the first equation that we get in x and y. The second equation we can obtain by taking this equality, angle C is equal to 3 angle B. Now I can first write angle C as 180 minus x minus y degrees, because the sum of the three angles is 180 degrees, and two of those angles are x degree and y degree. So the third angle will be 180 minus x minus y degrees. And now I have angle C is equal to 3 angle B. So 180 minus x minus y should be equal to 3 times angle B, or 3 times y. And from here I can get x plus 4y is equal to 180. So this is another linear equation in x and y. Let's call it equation 2. Now to solve this pair of equations 1 and 2, I note that the coefficient of x in the first one is 2 and in the second one is 1. So let's multiply the second equation by 2. That will give me 2x plus 8y equal to 360. And let's call this equation 3. Now we can subtract equations 1 and 3. So let me do 3 minus 1, and that will eliminate the x terms. So the 2x will get cancelled, and I will have 8y minus y, So that's 9y on the LHS, and on the RHS I will have 360 minus 0 or 360, and this gives me y equal to 40. And from y equal to 40 I can substitute this into the first equation, and I will get 2x minus 40 equal to 0, or x is equal to 20. So this means that angle A, x degree, is equal to 20 degrees, angle B, which is y degree, is equal to 40 degrees, and angle C, which is 180 minus x minus y, this is equal to 120 degrees. So this is exactly the same answer that we obtained in approach 1. The only difference is that in approach 1 we set up the equations in a single variable, and in approach 2 we assumed two variables, but essentially we did the same thing. So the answer is that the three angles are 20 degree, 40 degree and 120 degree. In question 6 of this exercise, we have to draw the graphs of the equations 5x minus y equal to 5 and 3x minus y equal to 3. Then we have to determine the coordinates of the vertices of the triangle formed by these lines and the y-axis. Okay, so let's start with the first equation, which is 5x minus y equal to 5. So let's make an xy table and find two xy pairs that satisfy this equation, 2 points that lie on the line for this equation, and then we will be able to draw the line corresponding to this equation. So if we substitute x equal to 0 here, then y becomes minus 5. So 0 comma minus 5 is 1 point on the line of this equation, and I could substitute x equal to 2, and that will give me y equal to 5. So I have taken values of x that give me integer values for both x and y, because that makes it easier to plot them. So the two solutions that I will plot for this first line are 0 comma minus 5 and 2 comma 5. Now let's take the second equation. The second equation is 3x minus y equal to 3. Once again, let's make an xy table and give two values to x that give us integer values for both x and y. So if I take x equal to 0, then y becomes minus 3, and if I take x equal to 2, that makes y equal to 3. So two solutions, 2 points that will lie on the second line are 0 comma minus 3 and 2 comma 3. Now let's plot the lines corresponding to these two equations. So here are what the lines will look like. So for the first line, the two solutions are 0 comma minus 5 and this point here, which is 2 comma 5, and this green line is the line corresponding to the first equation, 5x minus y equal to 5. Then for the second equation, this is 1 point, 0 comma minus 3, and then this is another point, which is 2 comma 3, and this blue line passing through these 2 points is the line corresponding to this second equation. So with that we've plotted the lines, and now let's find out the coordinates of the vertices of the triangle formed by these lines and the y-axis. So what are those coordinates? So one is this point 0 comma minus 3, this point here. Then one is this point 0 comma minus 5, which is this point here, and then one is this point, which is 1 comma 0. So these three vertices are the vertices of the triangle formed by the two lines and the y-axis, this vertical y-axis. And let me mark out the boundaries of this triangle. So this line joining 1 comma 0 to 0 comma minus 3, then this line 0 comma minus 3 to 0 comma minus 5, and then 0 comma minus 5 to 1 comma 0. So these three are the sides of the triangle. So with that, question 6 of this exercise is completed.
Hi students, being good at math is super important because it helps you do well at school, but more importantly, it opens the doors for you to the most awesome careers of the future. Having taught thousands of students, I can confidently say that every student can really excel at math, including you. So I've created something special to help you become a master of math. Go to qmat.com/leap to find out more. I'll see you there.